Welcome to Introduction to Computer Science, Networks. This is Lecture C. The component, Introduction to Computer Science, provides a basic overview of computer architecture, data organization, representation, and structure, structure of programming languages, and networking and data communication. It also includes some basic terminology from the world of computing. The objectives for this unit on networks are to define what a communication network is, explain the purposes and benefits of a communication network, explain the Internet and World Wide Web, their histories and their structures, describe different ways of connecting to the Internet, explain basics of network addressing, IP addresses and domain names, and how they can be leased or purchased from an Internet service provider, introduce network classification by the coverage size, describe different network topologies, outline different standards and protocols that govern wired and wireless communications. Describe benefits and disadvantages of wireless communication. Describe a typical wireless network setup. Describe network hardware. And finally, to introduce networking logical models and discuss Open Systems Interconnection, or OSI model. How a network is organized or laid out is referred to as its topology. Two types of network topologies exist. Physical topology details how the network is physically designed. In other words, how devices in the network are connected with wires and cables. Logical topology illustrates how devices appear to the user to be connected. In other words, how data flows through the network regardless of its physical design. First, consider physical topologies. There are many physical topology types. The main types are shown in the figure on the screen: ring, mesh, star, fully connected, line, tree, and bus topology. The next few slides show some of these in more detail. One physical topology is known as a bus. In the figure on the slide, each host is connected to every other host by a single network cable with connectors. Each green dot in the figure represents a host. If any cable breaks, then the whole network goes down. Obviously, this type of network was not very reliable or scalable and has not been in use since the late 1990s. Another type of physical topology is mesh. With mesh topologies, each host is connected to every other host in the network by a switch or by a direct connection to another host without the use of a switch. The image on the screen shows a full mesh topology, where each host is directly connected to every other host in the network. This type of physical topology usually relates to routers, not to computers, because when computers are in a full mesh, they are typically interconnected by a switch. In other words, all of the devices will connect to the switch, not to each other. Another physical topology is the ring. Within a ring topology, each host is connected to the network in a closed loop or ring. This is an uncommon network type, usually found in highly secured environments. Ring topologies typically use an electronic token passing scheme, which controls access to the network. By using this type of topology, only one machine can transmit on the network at any given time. The physical star topology is the most common topology type. It is the easiest to set up and maintain. In this type of environment, all traffic passes through the switch that is at the middle of the hub of the network. At the ends of the star are end devices. Examples of end devices are computers and printers. Note that an extended star topology exists when a number of switches are connected to each other. This diagram does not show any end devices. In an extended star topology, all hosts can communicate with all other hosts, assuming a proper design, Internet protocol or IP addressing, and appropriate network permissions. The Institute of Electrical and Electronics Engineers, or IEEE, creates and publishes networking and other standards. Wired networks are governed by IEEE 802.3 standard, while wireless networks are governed by IEEE 802.11 standard. Establishing standards is important since it ensures compatibility of products from various vendors. Protocols govern communications used by the various products you might install on your computer. For example, say that you purchase and install an Intel Network Interface Card, or NIC. Your friend installs a 3COM NIC on their computer. Both computers can communicate flawlessly over the network because both NICs adhere to the applicable IEEE standards for network communication. Internet protocols are a global standard. This ensures interoperability between the hardware and software installed on computers. For example, IP addressing is required for home and office networks to function properly. IP addressing allows any device with Internet or network access to communicate with any other device on the Internet. The Transmission Control Protocol Internet Protocol, or TCP/IP, transports Hypertext Transfer Protocol, or HTTP, across the Internet for delivery to its destination. HTTP is the Hypertext Transfer Protocol used on the World Wide Web. Protocols such as HTTP allow any web browser to talk to any web server. Network standards include Ethernet, Token Ring, Wi-Fi, WiMAX, the Wireless Application Protocol, or WAP, the Radio Frequency Identification, or RFID, and Bluetooth. These standards will be described in more detail. Starting with the Ethernet network standard. Ethernet gets its name from the physical concept of ether. In the late 1800s, scientists thought that some then-unknown medium was responsible for housing light particles as they passed through the air. The name they gave to this unknown medium was ether. Ethernet cables and Ethernet as a standard were developed between 1973 and 1975. Ethernet is encompassed and promulgated in IEEE Standard 802.3. Ethernet's standard defines the standardization and rules that relate to wiring and signaling. It defines frame formats and how large fields are within frames. Ethernet is widely used in wired networking. A frame is an electronic construct that organizes electronic communication into fields of fixed sizes. Switches and other devices are able to understand the contents of a frame and use information in its fields to forward electronic communication throughout the network. The Token Ring Network Standard was developed in approximately 1985 and is part of the IEEE 802.5 standard. Token Ring is named after its logical topology, since its physical topology is a star. In this type of topology, devices connect to each other, usually by a switch. When devices connect to a switch through an Ethernet cable, communicating devices need to possess the digital or electronic token that is passed around the ring. Again, this is a logical ring, so the token passes from device to device. Therefore, a device passes the electronic token to the switch, which passes it to another device, and so on. Devices pass the token until they need to communicate on the network. Then, they hold the token until they are finished communicating. In essence, Ethernet made Token Ring obsolete because Ethernet is much faster and easier to implement. To use a Token Ring network type, users must install Token Ring NICs and switches. The Wi-Fi network standard relates to wireless devices. It began its evolution in 1997 and continues today. Wireless communication is based on the 802.11 standard for wireless local area networks, or LANs. In fact, Wi-Fi and 802.11 are synonyms because they relate to the family of wireless protocols 802.11a, b, g, and the draft N protocol. The standard 802.11 defines throughput and frame formats that relate to the equipment being used for wireless communication. When communication moves from a computer onto a wireless NIC and then ultimately into the air, how does electronic communication get into the air? With a wired connection, how does the communication from a computer move from the NIC onto a piece of wire? All of this is governed by the 802.11 standard for wireless and the 802.3 standard for wired communication. The 802.11 standard defines frame formats. In other words, the standard defines the format of the electronic communication pieces so they can make the jump from the NIC onto the actual wire itself. 802.11a uses the 5.0 GHz wireless band for its communication. 802.11b and g both use the 2.4 GHz wireless band. Note that the 2.4 GHz frequency range operates in the same range as microwaves and older telephones. So a user communicating wirelessly in a home and running a microwave at the same time would experience interference to the wireless signal. The microwave would consume all of the wireless bandwidth, causing wireless communication to function less than perfectly, if at all. 802.11n, on the other hand, uses both 5.0 and 2.4 GHz frequencies for its communication. This is why 802.11n is so much faster than the 802.11a, b, or g types. The WiMAX network standard was developed in 2001 and is referred to as the IEEE 802.16 standard that relates to WAN wireless networking. It is the telecommunications protocol that provides fixed and fully mobile Internet access. Note that WiMAX is different from Wi-Fi. Here's an example to clarify this point. WiMAX access was used to assist with communications in the Aceh, Indonesia area after the tsunami in December 2004. WiMAX provided broadband access that helped regenerate communication to and from this province when no other communication was available. People with network devices were able to connect to the network using WiMAX connectivity. The Wireless Application Protocol, or WAP, is an open international standard for application layer network communications in a wireless communication environment. The standard describes a protocol suite. A protocol suite is a number of protocols that are grouped together, allowing the interoperability of WAP equipment and software with many different network technologies. The concept was developed in approximately 1997 and is still relevant today. Most uses of WAP involve accessing the internet from a smartphone, a mobile phone, or a personal digital assistant, also known as a PDA. The Radio Frequency Identification Standard, or RFID, incorporates the use of an RFID tag in an object and then communicates using radio waves. Most RFID tags contain at least two parts. First, there is the circuitry that stores information about the item related to the RFID tag. Then, there is the antenna for sending and receiving signals. Many organizations govern this standard, including the International Standards Organization, or ISO, and the International Electrotechnical Commission, or IEC. In stores, RFID tags are placed on clothing, expensive items, and items that are easy to shoplift. They are heavily used for inventorying medical supplies and medicine. In fact, in many medical offices, if an employee needs to remove medicine from a cabinet, the RFID tag records its movement and may even ask the employee to remove it from inventory. The IEEE 802.15 standard that is relevant to Bluetooth was developed in approximately 1994 and is evolving to this day. Bluetooth represents an open, wireless technology standard for exchanging data over short distances, usually about 30 to 50 feet from fixed and mobile devices. Bluetooth is used in devices such as medical implants, keyboards, mouse devices, cell phone headsets, and other devices. This concludes Lecture C of Networks. In summary, this lecture discussed different network topologies and different network standards and protocols.